In the previous examples, the equations were chosen so that the x and the y already had coefficients that would cancel each other out. In this example, it isn't that way, so we're going to have to complete step 1 of the elimination steps by changing one of the equations so that we can eliminate the variables. So in this case, 2x plus 3y equals 4 is our first equation, and the other one is 4x minus y equals 22. So choose something that seems appropriate to you. They suggest multiplying the second equation by 3 and then adding the two together. What that would do would be to change the coefficient on the y. So if the first equation stayed the same, but the second equation was multiplied by 3, it would look like this: 12x minus 3y equals 66. So I'm just going to write that here so I have some room to work. 2x plus 3y equals 4, and then the second equation was 12x minus 3y equals 66. Now, what I see is that I have the same coefficient with a different sign in front of it. So I'll just be able to add the two equations together to eliminate the y's. So 2x plus 12x is 14x. 3y plus negative 3y is 0y. That's what I wanted. I need to get rid of the y's. And 4 plus 66 is 70. So divide both sides by 14, and I'm finding out that x equals 5. So you'll see that the process of elimination can be very quick. Now take that 5 and plug it back into one of your original equations, either one, to solve for y. So 10 plus 3y equals 4. So I subtracted 10 from both sides to get negative 6, and I'm going to divide by 3. So y equals negative 2. And then let's just verify that answer. So 2 times 5 plus 3 times negative 2 equals 4. So that says 10 plus negative 6 equals 4. Yes, it does. And then the other one would be 4 plus 5 minus negative 2 equals 22. So that says 20 minus a negative means plus 2 equals 22. And that's good. Now for part D, each of your answers might be different. It's saying what other number could you have multiplied by the first equation by in order to eliminate the x? So if we go back to the original, 2x plus 3y equals 4, and 4x minus y equals 22. What I could have done is I could have multiplied the first equation by 2, so that I would have 4x plus 6y equals 8. So don't forget to multiply every term by 2. And then my second equation, 4x minus y equals 22. In this case, I could have subtracted both of the equations and eliminated the x term. And then just be really careful because I've got 6y minus negative y. Okay, so it's not 5y. 6y minus negative y means to add. So 6y plus y, 7y. And oops, I better add or subtract here. 8 minus 22, I was adding it. So 8 minus 22 is negative 14. So y equals negative 2, just like I found in the first case. Then you could take that number back to either of the original equations and solve for x. So subtract 2 from both sides. So I've got x equals 5. So my two answers would have come out the exact same way whether I changed the first equation or the second equation.